Hey guys, my name is Mike, and this is Math Tutoring with Mike. Hey, before we jump into our video, there are just a few things that I would like to review with you. The first thing is that I want to implore that at the end of this video, by the time that you reach the end of this video, I want to make sure that you understand the principles that we went over today in this video. So if you have to stop the video at any point in time, that you're confused, or if you have to rewind, I really want to suggest that you do that. The second thing is that after you've reached the end of this video, that you actually go back and try solving the example problems on your own. Doing this, I find, is very important with cementing the theories and cementing the understanding, that you actually understand what was reviewed. So, thirdly, chances are you came to this video with a specific problem that you had. If at the end of this video you realize that I have not addressed the specific problem that you are looking to solve, I invite you to leave me a comment or shoot me an email with your specific problem or specific question. And you have my word, I'll do my best to either preparing another video or reaching out to you personally how to solve that particular problem. Anyway guys, so on to our video. In this video, we'll be reviewing or understanding the powers of 10. The positive powers of 10 are easy to write. We'll see that they're easy to write. And that is because the exponent matches the number of zeros that you'd find in the product or the answer. And this is what I mean. For example, if we see 10 to the power of 2, then the exponent here is 2. And that would ultimately mean that the product would have 2 zeros. But we would also see that 10 to the power of 2 is 10 times 10, or 10 multiplied by itself 2 times. Okay, if we look at another example, we see 10 to the power of 3. And in keeping, we say the exponent, which in this case is a 3, the exponent would match the number of zeros that we see in our product or answer. So since the exponent in this case would be 3, then the answer would have 3 zeros. And similarly, we know that 10 to the third power is 10 multiplied by itself 3 times. 1, 2, 3. In the same way, we could apply the same principle if it was 10 to the power of 4. 10 to the power of 4 would mean 4 zeros in the product, and 10 multiplied by itself 4 times. 1, 2, 3, 4. Let's see what happens if we multiply or divide powers of 10. Let's see what happens when we multiply. So let's say we have a situation where we have power of 10 to the second power multiplied by the power of 10 to the fifth power. Anytime we multiply powers of 10 by itself with different exponents, what we end up doing is we end up keeping the 10, or in this case the base, to 10, and what we do is we just simply add the exponents. So in this case it would be 2 plus 5. So it would be 10 to the power of 2 plus 5. And we know 2 plus 5 is equal to 7. Okay, and how this would look if we expanded it out, we say that 10 to the power of 2 has 2 zeros. 10 to the power of 5 has 5 zeros. Actually, one more zero. Five zeros. 1, 2, 3, 4, 5. Okay, so in actual fact, when we multiply 1,000, 100,000 by 1,000, if you pull out your calculator, you'll see that it would actually have 7 zeros. Okay, so a much shorter way of working this out is just simply adding the exponents. Let's do another example. If we have 10 to the power of 4 times 10 to the power of 6, we see that the product is just simply adding the exponents. So it would be 10 to the power of 4 plus 6. And that would equal 10 to the power of 10. If we're dividing powers, instead of now adding the exponents, what we'll do is we're actually subtracting the exponents. Here's an example. Or why don't we use the same examples here? 10 to the power of 6 divided by 10 to the power of 4. Okay? What we do is we subtract 6 minus 4, and that would be 6 minus 4 is equal to 2. Okay? If we have 10 to the power of 9 divided by 10 to the power of 1, that's simply 10 to the power of 9 minus 1. 9 minus 1 will give you 8. How would we find a problem where we have the power of a power of 10? And by that I mean 10 to the power of 3 all to the power of 2. Why don't we go ahead and write that over? 10 to the power of 3 all to the power of 2. Yeah, easy to see, right? So in this instance, what we would have is we would have equal to 10 to the power of 3 times 10 to the power of 3. Why? Because it's 10 to the power of 3 multiplied by itself, right? And we actually have it as 10. And we know when we multiply powers, all we're doing is we're adding it, right? So it would be 10 to the power of 6. But in essence, what we can do is we can say, another way of solving this problem is if we can say 10, open bracket, 3 times 2. So actually what we're doing is we're just multiplying these two exponents here. Okay, and we know that 10 to the power of 3 times 2 is 10 to the 6. Hope that makes sense. Let's do another problem, so you'll see exactly what I'm meaning or referring to. If we have 10 to the power of 5, and then all of that is to the power of 3, we're saying in essence that's 10 to the power of 5 times 10 to the power of 5 times 10 to the power of 5. Why? Because our problem is telling us 10 to the power of 5 cubed. Okay, so 10 to the power of 5 cubed, this is exactly what it means. And if we remember one of our laws, whenever we multiplying powers of 10, what we're essentially doing is just adding all of the exponents. So 10 to the power 5 plus 5 plus 5. And we know that 10 to the power of 5 plus 5 is 5. 5 plus 5 plus 5 is equal to 15. Another way of doing this problem, as you showed you in our last problem, is if we just simply said 10 to the power of 5 minus 3, and if we just multiply the exponents here, okay? So 10 times 10 to the power of 5 times 3. And what we find is 5 times 3 is equal to 15. And the answer would be 10 to the power of 15. Same answer that we found here. So just to summarize, let's just summarize what we found here. We found 3 observations about the power of 10. And we can apply it to all powers with the same base. And that is, let's assume that whatever base we have, we call it A, okay? If we see that rule number 1, where we have the same base and we're multiplying them. Sorry. Let me start again. So we have A to the power of C times A to the power of D. It just equal A to the power of C plus D. Why? Because we're multiplying the same base. A second rule that we're observing is where we multiply, where we're dividing the same power now. We're dividing two numbers with the same base but different powers. And we find out that in order to solve this problem, we would keep the base and we would just subtract the exponents. So multiply, we add the exponents. Divide, we subtract the exponents. And then the last rule we saw is if we have A to the power of C and then all to the power of D. A rule here is where we just multiply the exponents, C times D. So you've made it to the end of the video. Good deal. I really hope that you understood what was reviewed today. Like I said earlier on in the video, I really think it's a good idea that you go back and try to solve the example problems on your own. That way you can prove to yourself and you can help assure that you actually understand the problems. Well, until next time, with another tutoring session, another math tutoring session with Mike. See you guys.